In the United States, there's a pencil that has shaped the future of millions, the iconic number 2 pencil. But have you ever wondered how that pencil is actually made? Beneath its simple appearance lies a manufacturing process engineered with remarkable precision. The core, made from a carefully balanced mixture of graphite and clay, must be ground to a fine powder, blended evenly, extruded into thin strands, and fired at high temperatures to reach its ideal hardness. Meanwhile, the wooden body undergoes its own journey, from kiln-dried timber to grooving, shaping, and being coated in multiple protective layers of paint. In this video, we'll follow that journey in full, from raw materials to finished product, to uncover the exacting craftsmanship behind a small yet essential tool that's left its mark on classrooms, test papers, and the American dream itself. In the state of New Jersey, there's a factory that has been making pencils for over 130 years, since 1889. It's called General Pencil, one of the few remaining companies in the U.S. that still preserves many manual processes in an increasingly digital world. While industrial machines are part of the operation, the factory continues to honor its tradition of craftsmanship, where human hands still play a central role in each step, from placing the graphite core to final packaging. And here's something that might surprise you. A single pencil, if used continuously, can draw a straight line up to 56 kilometers long. That's far enough to sketch a seamless path from the Statue of Liberty in New York all the way to Newark International Airport and still have a few kilometers to spare. So let us ask, have you ever truly used up an entire pencil, or do they always seem to disappear mysteriously right around the halfway mark? Logging and wood processing. To craft a complete pencil, the journey doesn't begin in the factory, it starts in the forest. Wood is the backbone of the pencil body. To ensure stability, workability, and a clean aesthetic, leading pencil manufacturers choose softwoods with straight grains that resist warping and are easy to cut. The most prized among them is California incense cedar, not only for its distinct natural aroma, but for its resistance to cracking and its ability to hold shape during the drying process. These logs aren't harvested at random. They come from carefully managed tree farms where every tree cut down is replaced, ensuring a sustainable supply chain for the pencil industry. Once harvested, the logs are cut into uniform lengths and loaded onto specialized trucks headed for the mill. And from there, the transformation begins, as each rough, ordinary block of wood takes its first step toward becoming something far more refined. Once the cedar logs arrive at the factory, this raw material must now be processed with near-perfect precision. The logs are fed into specialized saws and cut into thin sheets known as slats. Each slat measures just 5 to 6 millimeters thick, precisely enough to form 1/2 of a pencil's body. But not every piece makes the cut. The slats are carefully inspected, both by sensors and by trained eyes, to detect flaws, warping, knots, surface cracks, anything that might compromise the integrity of the final pencil. The slats that pass inspection move on to the next stage, grooving. Each piece is guided through a milling machine that carves a series of shallow grooves along its length. These channels are designed to hold the pencil core, and their placement must be exact. A groove that's even slightly off-center could cause the core to break when sharpened or during use. To finish the process, a thin coating of oil or wax is applied to the surface. This not only protects the wood, but also gives it a smooth texture, making the next stages of assembly easier, cleaner, and more precise. Pencil core manufacturing process. Once the wooden body is ready, the next element to prepare is the soul of the pencil, the graphite core, the material behind every word written and every sketch drawn. Graphite, often mistakenly referred to as lead, is a crystalline form of carbon made up of layered structures that allow it to glide smoothly across paper. This unique mineral is primarily extracted from open-pit mines in countries like China, Brazil, Mozambique, and India. When a natural vein of graphite is discovered, heavy machinery or controlled blasting is used to break it away from the surrounding rock. The raw ore is then transported to a processing facility, where it undergoes crushing and multiple stages of refinement to remove soil, stone, and trace metals. The goal is to isolate graphite powder with a purity level of over 90%, the minimum standard for pencil cores. The quality of this graphite, from its softness and sheen to its particle size, graphite plays a crucial role in determining how the pencil feels in hand, how smoothly it writes, and how durable the core will be with time. Once the purified graphite is ready, the next challenge is transforming that raw powder into a fully formed pencil core. To achieve this, the graphite powder is blended with clay, which acts as a structural binder. The ratio between graphite and clay is what defines each pencil's writing characteristics. More clay results in a harder, lighter core, typically marked as H grades. More graphite, on the other hand, produces a softer, darker, and smoother stroke, categorized as B grades. The mixture is kneaded thoroughly in industrial mixers until it reaches a perfectly even consistency. Next, the graphite clay paste is extruded into long, thin strands, much like spaghetti, only just a few millimeters in diameter. These delicate threads are then carefully dried to remove moisture before being fired in kilns at temperatures ranging from 1,000 to 1,200 degrees Celsius. This high heat treatment hardens the core and locks its shape in place. Finally, each core is dipped in oil or wax, a subtle yet essential step that reduces friction, ensures a smooth writing feel, and minimizes dust as the pencil glides across the page. Alongside traditional graphite cores, pencil factories also produce another type of core, the colored pencil lead. Unlike traditional pencil cores, which are made from graphite and clay, colored leads are composed primarily of pigment, blended with wax, oil, and fillers such as kaolin or talc. There's no single formula for colored leads. It varies depending on the product line and intended use. For example, colored pencils made for students often prioritize softness and ease of application, using more wax for a smooth, blendable texture. In contrast, high-end artist-grade pencils demand greater color intensity, finer grain, and long-term durability. So the mix may include oils, resins, or specialized binders for optimal performance. Once blended into a uniform paste, the mixture is extruded into thin, delicate strands, similar in shape to graphite cores. Unlike graphite, colored leads are not fired in kilns. Exposing them to high heat would degrade the pigments and alter their color quality. Instead, they are gently dried to maintain their form, then cut into standard-length segments that match the size of a finished pencil. Assembly and finishing process. Once both the wooden slats and the pencil cores are ready, the manufacturing process enters a critical stage, combining these two components to form the first complete shape of a pencil. On the production line, a slat that has been precisely grooved is placed onto a conveyor system. These grooves are positioned with technical accuracy, each one measured to the correct depth and spacing to perfectly fit the type of core being inserted, graphite or colored. Leads are then placed into each groove, either automatically or by hand, depending on the factory setup. For premium or delicate pencil lines, especially those with softer or more fragile cores, manual placement is often preferred to reduce breakage. Next, a second slat carved with identical grooves is coated with a thin layer of adhesive along the grooves and is then carefully aligned and pressed onto the first slat, forming a sandwich-like structure with the core locked between the two wooden halves. This unit is then fed into a high-pressure press where calibrated force ensures the glue spreads evenly and the core is held firmly in place.
Some modern factories enhance this process using heat pressing, or a combination of temperature and pressure to accelerate drying and increase bond strength. Even now, the pencil block isn't quite ready to be cut. It must rest for a set period, cooling and stabilizing so the adhesive can fully cure and the core remains precisely fixed at the center before the next phase begins. Once the bonded pencil block has been firmly pressed and allowed to cool, the next step is to cut it into individual pencils, each one taking on the familiar shape we all recognize. The long sandwich block with the graphite core sealed inside is fed into an automated cutting system. Precision saws slice into standard length pieces, typically 17.5 centimeters, matching the size of most pencils found in classrooms and offices around the world. These small sticks are the rough forms of the finished pencils. Next, each piece is shaped using a profiling machine. Depending on the brand and design, the pencil body can be rounded, hexagonal, or even triangular. Each form carefully chosen to affect how it feels in the hand, how it rolls or doesn't on a table, and how comfortably it writes. After shaping, the pencils go through another round of inspection, both by machines and human eyes, to weed out any with cracks, chipped edges, or off-center cores. Only those that meet the mark will continue down the production line, inching closer to becoming a tool of expression used by millions. When the pencil shape has been fully defined, the next step is to give it a coat of color. After shaping, the pencils enter an automated painting line. Each one typically receives between 3 and 6 coats of finish, starting with a base primer, followed by the main color, and finishing with an outer protective layer that guards against moisture, scratches, and wear from daily use. While the classic yellow remains a timeless symbol of traditional pencils, modern manufacturers offer a wide spectrum of colors: deep burgundy, jet black, navy blue, or even a natural wood grain finish for a more organic look. The entire coating process is carried out by industrial spray machines paired with heat curing systems that ensure each layer dries quickly and adheres evenly. Once the final coat of paint has been applied and thoroughly dried, each pencil is ready for a crucial step that gives it identity: the printing process. On the printing line, every pencil is gently rotated through a system of rollers or hot stamping machines. These imprint key details directly onto the wooden barrel, such as the brand name, product code, and the graphite grade like HB, 2B, or H in some cases. The country of origin or batch number is also included for traceability. For premium pencils, more sophisticated techniques are used, including heat transfer printing, silk screening, or metallic foil embossing, giving the text a polished and durable finish. Some major brands even offer personalized engraving, allowing users to add their names or messages, turning an everyday tool into a thoughtful and uniquely personal gift. Once the pencil body is complete and the lettering has been printed, some pencil models still require one final detail at the end: the eraser. This eraser assembly is not just a handy addition, it's also a symbol. What transforms a simple pencil into an all-in-one tool for students and everyday users. The process begins with the creation of the metal ring, known as the ferrule. At the same time, the eraser, usually made from a blend of synthetic rubber, softening agents, and mild abrasives, is molded into cylindrical shapes and cut to the standard length. Assembly is handled by automated machines. The eraser is first pressed into the ferrule, then the entire unit is firmly crimped onto the pencil's end. The pressure applied must be strong enough to secure the parts tightly, but not so much that it cracks the wood or deforms the metal. Though small, the eraser is one of the most frequently handled parts and often the first to reveal any flaw if not properly attached. That's why in modern factories, this step is inspected just as thoroughly as any other phase of the production line. After full assembly and thorough inspection, some pencil models go through one final step before packaging: sharpening the tip to reveal the writing core. This process is typically reserved for retail-ready pencils sold in pre-sharpened packs. To do this, the pencils are fed into a specialized sharpening machine, where a fixed blade carves the tip at a precisely calculated angle. Depending on the hardness of the core,
the type of wood, and the intended use, the system adjusts the cutting depth and speed accordingly, ensuring the graphite is exposed evenly, cleanly, and without chipping. When everything is complete, the pencil is finally ready for packaging and a final round of quality control. Each pencil passes through a thorough inspection system where it is checked for straightness, core alignment, eraser stability, paint uniformity, and the sharpness of the tip, if pre-sharpened. Only pencils that meet all these standards move on to be sorted and packed, typically in sets of 6, 12, or 24, depending on the target use and market. Packaging is tailored to the product's positioning. For standard models, the pencils are placed in cardboard boxes or transparent plastic cases. For premium lines, packaging may include tin boxes, wooden cases, or eco-friendly recycled materials. Once packed, boxes are stacked into larger cartons, sealed, and sent to distribution warehouses, ready to begin the next journey, reaching the hands of users all around the world. Conclusion. Though it may seem like a simple tool, each pencil is the result of a meticulous journey, from cedar forests in California to graphite mines in Africa and Asia, from high-speed production lines to delicate steps that still rely on the human touch. If you found this journey fascinating, don't forget to hit like, leave a comment below, and subscribe to our channel. Join us as we continue exploring the incredible processes behind modern manufacturing and timeless craftsmanship.